Hello again. Period 4 is here. Janine, John, everybody's here. Gabby. Today, we're going to do a problem on sliding down a banister. Now, the banister has a coefficient of friction of 0.2. Slippery, but not terrible. It's not like ice or water on porcelain, but it's still, anything less than 0.1 is very slippery. But that's okay. You'll slide. Now, it's going to be 30 degrees. The person who is sliding down the banister has a mass of 62 kilograms. Here is the picture, the free body diagram. I have my weight to straight down. This is my normal. The normal is actually straight up, of course. So that's going to be negative. But we don't really use that negative. We just say it's the normal. We ignore the sign of that. A little weird, but I can deal with that. Okay, now, the FP is that tendency to slide down an incline. It's less than your weight, but the steeper that incline, the more you feel that tendency to slide. Friction is going to be contrary to that force, contrary to FP. The direction of motion is traditionally taken as positive. You're sliding down the banister, so it's going to be plus. The friction, therefore, will be minus. Now, this is the problem. The problem is simply, right now, part 1, define the force of friction. Very straightforward problem. Now, I need to find several things. Let me get rid of this. All right, this will be my workspace. I know that Fw is going to equal 620 newtons. I like to round G to 10. Just makes things easier to calculate. And I know that Fn is going to be 620 cosine 30. Because we're looking for Fn. Adjacent over Fw equals cosine 30. Cross multiply. You get 620 times cosine 30. And that's going to be 620, I did it over here, 537. 537 newtons, right? Double check that on your calculators. Don't let me get away with anything, all right? Now, I know that the coefficient of friction is 0.2. I know that the force of friction is going to be mu Fn. I know that. So what is 0.2 times 537? What is 0.2 times 537? And that's going to be 107. All right? That's it. That's the end of part 1. I'll be back for part 2 and we'll extend the problem. Okay? We'll extend the problem. Thank you very much.